Today we're going to continue our discussion about solving systems, but this time we're going to solve systems using elimination. Sometimes the elimination method is called the addition or subtraction method because we're going to do just that. We're going to eliminate a variable by using addition or subtraction. In order to use this particular way of solving a system, we have to make sure both equations are in standard form. Now, we talked about standard form back in Chapter 5. You have to remember that standard form is ax plus by equals c. So you want to make sure all your variables are on one side, constants on the other. Now, just like when we solve systems using substitution, solving systems using elimination, the steps when I write them out look a lot more confusing than what the math actually is. So I'm going to quickly go over the steps, but it'll make a lot more sense once we actually start solving the problems. Basically, we're going to pick a variable to eliminate, and it could be x or y. Now, you want to make sure you have opposite coefficients, and opposite coefficients means something like maybe plus 3y and minus 3y, or negative 10x and positive 10x. Opposites plus and minus of the same number. What will happen is when we add the equations together, we'll end up eliminating that variable because opposites are equal to 0. However, sometimes we're going to have to change the equation in order to make opposite coefficients, and I'll get to that later on. Once we have opposite coefficients, we add the columns together, which is going to give us one variable, and we solve for that variable just like we did yesterday, and then we take that answer and plug it into one of the original equations to get the other variable, again, just like we did yesterday. You can check your answer in both original equations to make sure that you have the correct answer. Okay, so looking at number 1, what is the solution of the following system? We're going to use elimination. First of all, we want to make sure both of our equations are in standard form. Ax plus by equals c, which they are. And the next thing is you want to make sure we have opposite coefficients for either the x or the y. Either the x or the y. So if I take a look at my x's, I have 2x and 6x. Those are not opposites. But if I look at my y's, I have 5y and negative 5y. Those are opposites right there. Once I have opposites, I can add the two equations together. The reason I'm adding the two equations together is so that I can eliminate one of the variables. 2x plus 6x is 8x. 5y minus 5y is 0. They've gotten eliminated. And 17 minus 9 is 8. Now I have a nice easy equation. I can solve for x. So x is equal to 1. Now keep in mind we have to get the other variable so we can find our ordered pair. We're going to substitute that x into either original equation. I'm going to pick the first one, not for any particular reason. Now I know that x is equal to 1, so I'm going to substitute a 1 in for x and solve for y. And this step is the exact same thing as what you saw yesterday in substitution. Keep in mind, once you have your x and your y, you want to write your answer as an ordered pair. When you check, you're going to substitute that x and y into both original equations. Okay, make sure you're substituting into both. Okay, next question. What is the solution of the following system? Again, we're going to use elimination. Keep in mind we want opposite coefficients. Both of my equations are in standard form, ax plus by equals c. If I look at the x's, I have a negative 2 and a 7. Those are not opposites. And if I look at the y's, I have positive 15 and negative 5. Those are also not opposites. But what I can do is I can multiply this second equation by 3. And I'm going to end up with a 15y, or negative 15y when I do that. So I'm going to leave the first equation alone, negative 2x plus 15y equals negative 32. And I'm going to distribute that 3 to every single term in the second equation. 3 times 7x is 21x. 3 times negative 5y is negative 15y. And 3 times 17 is 51. Now I have opposites for my y's, so I'm going to add the two equations together. Negative 2x plus 21x is 19x. 15y minus 15y is 0, and negative 32 plus 51 is 19. Now I have a nice easy equation to solve for x. Divide both sides by 19, and x is equal to 1 again. Keep in mind we still have to find the y. It doesn't matter which equation you go back to find the y. I'm going to use the second equation, 7x minus 5y equals 17. Now I know that x is equal to 1, so I substitute 1 in for x and solve for y. Again, this step is just like we did yesterday with substitution. There is no difference there. So y is equal to negative 2. So my answer is the ordered pair 1, negative 2. That's where the two lines intersect. Okay, third example. Again, we're going to use elimination to solve the system. Once again, this system is in standard form, but once again, I don't have opposites. I have a 3x and a 4x, and a 2y and a 3y. So what I need to do in this situation is, not only am I going to multiply one equation by a number, I'm going to have to multiply both equations. Now, I've been spending time eliminating y's, so what I'm going to do is I'm going to eliminate x's. If I multiply this first equation by 4, I'm going to end up with a 12x. So if I multiply the second equation by 3, I'm also going to end up with a 12x. But the problem is going to be I'm going to have both of them being positive. And remember, with opposites, I need one of them positive and one of them negative. So I'm going to use the negative in the second equation, not for any particular reason. I could have multiplied the first equation by negative 4. So I'm going to multiply every single term in the first equation by 4. I'll get 12x plus 8y equals 4. And I'm going to multiply the second equation, everybody, by negative 3. Negative 12x minus 9y equals positive 6. Now notice my x's are opposites, positive 12, negative 12. I add the two of them together, and because my x's are opposites, they're going to cancel each other out. 8y minus 9y is negative 1y, 4 plus 6 is 10. Divide both by the negative 1, so y is equal to negative 10. Now I have to go back and get my x. Again, it doesn't matter which equation you use. I'm going to use the first equation. 3x plus 2, and I know now that y is negative 10. And I'm going to simplify this to solve for x. So now I have my ordered pair 7, negative 10. Keep in mind that once you have one of the variables, the first variable, the second part is just the same as yesterday when we solved by elimination, or I'm sorry, substitution. Okay, we have one more. We're going to talk about a word problem now. And if you want, you can use the link that you see there and go check out the video. Basically, all the video is showing you who Tweedledee and Tweedledum are based on Disney's versions of Through the Looking Glass by Lewis Carroll. So in the Lewis Carroll book, Through the Looking Glass, Tweedledum says, the sum of your weight and twice mine is 361 pounds. And Tweedledee replies, the sum of your weight and twice mine is 362 pounds. Our goal is to find both of their weights. Keep in mind that with a word problem, I need to start with my let statements. Since I'm looking for the weights of both Tweedledee and Tweedledum, that's going to be my variables, let x equal Tweedledum's weight and let y equal Tweedledee's weight. Okay, so now keep in mind we're talking about systems, so we need two different equations, and those equations are coming from what Tweedledum and Tweedledee are actually saying. So in the first sentence, Tweedledum, who's x, says, the sum of your weight, he's talking about Tweedledee, so the sum of your weight, Tweedledee's weight, and twice mine. Keep in mind it's Tweedledum that's talking, so twice mine would be 2x. He says the sum of your weight and twice mine is 361 pounds. But then Tweedledee replies, now keep in mind Tweedledee is y, Tweedledee replies, the sum of your weight, meaning X, and twice mine, Tweedledee is Y, so twice Y, is 362 pounds. So now what I want you to notice is these equations are kind of in standard form, but not really, because that first equation doesn't have the X term coming first. So I'm just going to rewrite that first equation. Instead of saying Y plus 2X, I'm going to make him say 2X plus Y equals 361, so that he's in standard form. Now for this particular these particular equations here, this system, it might be just as easy to solve this system by substitution rather than elimination. But we're going to stick with elimination. I don't have opposite coefficients, so I'm going to force this to have opposite coefficients by multiplying the second equation by -2. I could have multiplied the first equation by -2 to eliminate the y's as well. The first one stays the same. And the second one, I'm going to distribute the -2. So that's going to be 724. And now that my x's are opposites, I'm going to add the two equations together. 2x minus 2x is 0. Y minus 4y is -3y. And 361 minus 724 is -363. Divide both sides by -3. Keep in mind you should get a positive number because we're talking about the weights of Tweedledee and Tweedledum, so we have to have positives. So now I found out that Tweedledee was 121 pounds. Now I have to find out how much Tweedledum weighs. So I'm going to take that y and substitute it. I'm going to choose the first equation. So now I know that y is 121. I'm going to subtract 121 on both sides and solve for x. So Tweedledum weighs 120 pounds. So that's solving systems using substitution. Again, keep in mind you want to make sure you have opposite coefficients for elimination. So your homework is on page 382, 7, 15, 19, 27, 29, and 31. What I'm going to do is I'm actually going to give you the answers for the homework so you know if you're doing the questions correctly. I did not give you the answers for 29 and 31 because those are more open-ended questions, meaning your answers could change based on how different people respond. So those are the answers for your homework questions, and with the remaining time that you have left, you are expected to be working on your homework.